Hello again. We're going to try a version of an inclined plane problem, as you can see here, but this time with friction. And this one in particular is actually a pretty interesting one, as you'll see. Now, I like to do all the algebra first and then plug in all the numbers later. You can actually do the opposite. You can plug in all the numbers and then solve for what you're looking for. But let's see what we're given. Once again, we have the free body diagram. And this time, we have static friction that's holding the block in place. And this is actually supposed to be resting on a ramp that if once, or a board, you're trying to find the maximum angle that it can have before it starts to slip down, before the maximum of static friction is reached and it moves to sliding or kinetic friction. Okay? So in this case, we are given the mass, not that big, and we are even given the coefficient mu s of between the block and the ramp. And take note, that is specific to that combination and that combination alone. If it was a different block, it'd be a different coefficient. If it was a different type of ramp, if it's a different angle, that won't change it. And that's it, pretty much everything that we're given besides the free body diagram itself. And we're trying to find essentially the maximum angle. Now, this is not a maximization problem. This is simply just an algebra problem. And the formulas that we'll need are actually still Newton's laws of motion. Actually, that. And we'll need the formula for static. The maximum at static friction is mu s. I like to use capital N. Okay, and this one actually separates that the forces of all the x components and the y components also add up to 0, as you can see here. Those cancel out because it's not moving down, and those the normal force and the cosine component or the y component of the weight are also equal and opposite to each other or cancel out. Okay? And so how do we use that to solve for theta? Where does theta even come from? And I'll give you a hint that somehow it has to come from one of the trigonometric functions. Okay, this is the only place where we have theta, take note. Those two. So that will actually come from those two. So check this out. So we start with what we know, that the block is not going anywhere. And what that means is that all the forces on the x equal to 0. All the forces on the y are also equal to 0. Okay? And let's see how many forces there are. In the x, let's take a quick look at the x here. The friction is actually going in the negative direction, and the mg sign is in the positive. Here, the normal force is positive in the y, and the mg cosine, as you can see, is already in negative. So for the x, it was just minus fs plus mg sine theta, if you want to take a peek. Okay? Right there. And what I can do with that is I can simply bring this to the other side, and I get this equation. That the magnitude of the static friction is equal to the magnitude of the x component of the weight. Boom. So that we'll save that and keep that for now. We go to the y. And here it's just the normal force going up minus mg cosine theta. And so we just bring this aside, and we're going to get equation that the magnitude of the normal force equals mg cosine theta, and we'll actually hold on to that as well. But wait a minute. Friction, the force of static friction, is equal to mu s n, right? And wait a minute. We have n is equal to mg cosine theta. Alright? And wait, one more. Static friction is equal to mg sine theta. And hopefully you're able to see where I'm going with this. This becomes now this is interesting because we were given the mass, but will we even need it? Two things we don't actually need in here. mg, and it comes up to a very nice equation that sine theta mu s cosine, or divide both sides by cosine, boom. Okay, we're given the fact that mu sine is actually the ratio of the sine or cosine, or that's actually equal to tangent. Now remember, this was only used to find the maximum angle that static friction will still hold on to the block. So we need to solve for theta. One more step. And that's simply inverse tangent of mu s, which is less than 1, but tangent can be more than 1. Okay? And then plug and chug. What was the 0.35? So we didn't even need that mass at all. That's -1. Or arctangent. Essentially means the same thing, and that will give you an angle of not that big of an angle, really. So, word to the wise, be careful when driving on inclined planes that are bigger than 20 degrees. Okay, watch out for that. Okay, hope you're able to follow along. Notice that we used a very simple trig function, or trig identity rather, to solve for this. And this formula, students like to put on their formula cards. Take note, this does not work all the time. We're not involved any force pushing on the object or pulling down on it, not kinetic friction. So this is only for a very specific case where you're just trying to find the maximum angle that the block will still hold on given a certain coefficient, a certain combination of surfaces. Okay? Hope you can follow along. Hope you understood. Hope it helps. And enjoy.